So welcome everyone to this session, Development Open Days 2021 here at Dell Technologies. Thank you very much for joining this session. This session will be about Docker, the technology Docker, and I will show short demos how to use it. Now, the overall goal of this session is to introduce you with this technology. It's a cutting-edge technology of nowadays, and a lot of companies all around the world and a lot of great software developers are using this technology. And the aim of this session is just get you familiar with terms connected with Docker and the basic idea of Docker and the goal which we are trying to solve with the Docker and the way how to use it as a beginner, how to start with learning it, how to install it, and so on. Okay. So as Marek mentioned, there is a way you can ask me questions. As you can see in your view, there is a Q&A section and you can write the questions. As Marek mentioned, there will be 3 parts. After each part, I will make a short break to go through the questions. We can just choose some of them. Like this session is for beginners mostly. Like feel free to ask any questions, but I will choose first the simple ones so the beginners can learn something new from it. If you are interested into more details and going into more details, feel free to reach out to me after the session, right? As Marek mentioned, there are even like visitors and viewers from outside of the company. So I will try to use the language so everyone can understand what I'm saying. I will not talk about the very domain specific stuff which is in our company here and so on. So let's continue. So who am I? My name is Michal Hucko and I'm working here at Dell Technologies as a machine learning DevOps engineer. This is quite tricky, like it's called MLOps, it's a shortcut for it. And the main goal of my position is to deploy machine learning models into a cluster of servers, leveraging technologies like Docker and Kubernetes, right? So my main goal is to make an as efficient process of scoring and predicting as possible, right? I'm also a YouTuber and you can find my Slovak YouTube channel. It's called Informatika s Mišom at YouTube. And in my free time, I really like to teach people how to code and to talk about the technology, the modern technology of nowadays. So if you're a Slovak and you speak Slovak, you can reach out to Informatika s Mišom. You can find me there. I also had an English channel. It was called IT, and it's still called IT Guy Michal. And 1 year ago, I used to post there some tutorials and lectures. And accidentally, like you can find also some Docker lectures there. So if you are interested in this kind of stuff, you can find there some older versions of this lecture. It's called IT Guy Michal. I'm working with Docker currently more than 4 years, and I have experience mostly in the field of machine learning and deploying of the machine learning models, right? And I like to teach the programming, right? So let's go. So what is the goal? What we are going to solve with this Docker technology stuff, right? So everything what we're going to talk about is regarding the deployment of software. And now let's discuss what is the deployment of software, right? So on one side, when you are developing a software, you are mostly working inside your PC or your dev environment if you are working in some company and stuff like this, right? So you have your developer PC on your left side. This is your PC. And you are building their applications, right? And modern applications can be quite complex. You can use some REST APIs or some different services. Like you can imagine it like if you are building an e-store, you can have there like a shopping cart service and payment service. You can have their multiple databases, right? This is quite common, right? You can have relational database and then some non-relational databases for your stuff, right? And then after you finish the developing of your application, you want to provide your application to the people, right? To visitors, to your paying customers and stuff like this. So, and there is this step of transferring your application from your developer PC into a production, right? And it's quite common to use production servers to deploy your applications, right? And that's quite common, right? And once upon a time, people were building monoliths. And now, what is the monolith, right? Your application can consist of different parts, right? And monolith means that everything is inside, let's say, one script or it's running as one thing, right? You cannot like separate each part of this application, like the REST API, DB1, DB2, as a separate components, because you decided to build it this way, right? And this was a common practice like a couple of years ago. And the problem here was like, yeah, we got this application, right? It's a monolith, so everything is on one place. Everything is very tightly coupled. Everything depends on one another, right? And now we take this application and we deploy it to a production server. Now, there can be a lot of problems with this approach. One of the problems is like, what if we have only one production server, but we want to deploy multiple applications? This is quite a common practice in, smaller companies. They don't have enough money for a lot of servers, right? So they have just one server, and they, for example, want to develop multiple applications for different customers and stuff like this. So they don't want to just, spend the whole production server for one thing, right? So you want to be cost efficient. And the problem here is now, okay, Misho, so how do we do it so we can leverage the full potential of our production server to deploy multiple applications? Yeah, this can be funny, right? So this is one of the topics which I want to talk about today, right? So when we go next, there are the problems with this approach, right? What if the operating system of the production server where we are deploying this application needs an update? So we need someone experienced who is like responsible for deploying this application into production server. Then we need someone who has knowledge of this server and the updates of the server, right? What if we want to change the server over time? Let's say in the near future, we just want to deploy this application here for 1 year, but next year we want to migrate to a bigger server or to a smaller server because we don't have enough money, right? What should we do then? We will hire another DevOps guy because DevOps people are mostly the engineers who are trying to solve this problem, right? Like me. So we are mostly working in a field of like deploying these applications. In my case, we specialize in deploying the machine learning applications, but you can think of any other applications also, right? So what if we want to change the server? What if the application needs some major updates, right? We want to update the application and the application is in the production server. So there needs to be someone who will be like constantly updating the application. What if we want to scale? Now the scale means like, imagine you start with a smaller, customers, a small number of customers, right? You have 100 customers per month. But what if you have 1,000 customers later and your production server isn't enough? It's too small for handling that many requests and stuff. How are you going to scale? Meaning how you will make your application available for more people and so on. These are the problems which you have with monoliths and which are very hard to solve, or you need to pay some good money for good engineers to fix this problem. Now, what is the solution? Let's talk about something which is called a microservice architecture. So I was talking about the eShop, right, over here. So everything is on one place, everything is very tightly coupled, and the REST API cannot exist without the DB1 or DB2, right? So it's very, it's connected. Now, there is an approach which is called the microservice approach, and this approach is based on the idea that your application can be split into multiple services. Now, and I'm using a very popular example of this eShop. I think everyone on the internet is using this example. I couldn't find something else which can fit my needs, so I decided to reuse it, right? So imagine an eShop. eShop consists of different functionalities, right? So for example, you are selling some shoes. So you have there a catalog for shoes. You are maybe considering giving the opportunity for your customers to have a shopping cart there, right? So maybe you have a service for shopping cart and you have a service for handling the payments, right? For example, there is a payment with card, there is a payment with PayPal and stuff like this, right? So now the microservice approach is that you build this application as a separate components, separate services. So you have your catalog service, which is responsible for only like getting you and extracting the catalog data from database. You have your shopping cart, which is responsible for storing the ordered items of your live customers. And you have your payment service, which is responsible for handling the payments. This service can exist independently, right? So in the future, you can reuse this service, for example, on your other eShop. And you can reuse also the shopping cart and catalog, right? So as you can see, this approach is much more like useful and efficient. But the problem with the monolith is that in the monolith approach, each of these components is like, it looks for the monolith as a separate application, right? And when you are deploying the stuff as a monolith, it's a problem because in this way, you will need to set up somehow the production server to run, in this case, 3 separate monoliths, right? So how are you going to solve this problem? Now, and let's talk about something else, right? Having this microservice approach, you can scale. For example, you see that the shopping cart service is fine. It can handle 1,000 visitors, but the payment service has some problems. So you will scale only this payment service, and you will leave just, for example, one instance of a shopping cart. Now, thinking about the scaling process can be hard if you are a beginner and you never really like deploy something into the production. But you can really think of this as a separate server. So each of these red and blue box is a separate server, right? So when we talk about scaling, you open a separate server, only one separate server for shopping cart, but you open 3 separate servers for payment because a lot of people are paying and you need to have more of these payment services, right? So you need 3 servers at the same time, while you need only one server here. And now, as you can see, by splitting the application into the microservices, this gives us the opportunity to scale each service separately on different scale, right? When we had previously this monolith, there was no chance to scale our DB1 on multiple servers or REST API on multiple servers. I'm talking about servers, but basically in practice, it's not like a server, right? So in the monolith approach, we didn't have this chance. But when we start to use this microservice architecture, we have this opportunity to scale the things. Now, but how do we achieve this microservice architecture, right? We need to somehow leverage only one production server for, let's say, 3 separate things at the same time. And the answer is virtualization, right? So virtualization is the solution. So what is it? It allows us to create a separate environments within one server. When we talk about servers, you can really think of a PC, a simple PC. We can run separate operating system instances for different applications within one server. I will shortly come to this part, but you can think of virtualization. Most of the time, the virtualization is connected with Docker or virtual machines, right? So first, let's talk about virtual machines. How does it look like? I have here this diagram, and it can be challenging to read, but you can think of it this way, or you should read it this way. There is our server at the bottom, right? Which is running some operating system. Think of operating system as Windows, or in this case, you should rather think of it as a Linux, because servers and Linux, this goes well, not Windows, but yeah, think of it as a Linux, sorry. And now by using this virtualization, you are creating a layer on the top of your operating system, which is called a hypervisor, right? And there are very popular hypervisors like virtual machine, VMware or VirtualBox or any other hypervisors. And these hypervisors allows you to create a separate operating systems running inside your system. Now, you can have a separate operating system in your operating system. So each of these 3 columns, like SQL, REST API, or SMTP server in this case for sending mails, is a separate running instance of operating systems. But behind the scenes, everything is running only on one server, right? And this is how we can solve the monolith problem. Thanks to the virtualization, we can create the separate instances, in this case, of a whole operating system, thanks to virtualization. And we can run a separate, like SQL, this is a database, REST API, when I say REST API, I mean some backend, which is responsible for handling requests, or SMTP server in this case, that's the thing which is responsible for sending mails. Now, this column is called a virtual machine. And there are a lot of disadvantages of this approach. Let's talk about them. So what are the problems of virtual machines? Or VMs, that's a shortcut for it. So VMs are very big. When we come back, this whole column needs to have the whole operating system, all the binaries, the applications which you have inside your Linux, different distributions. So you can think of it like this is a separate distribution, like here is running Ubuntu, here is running Debian or something else, or you can really think of it like here is running Linux and here is running Windows, right? So the whole operating system needs to be created with this virtual machine approach. It takes time to spin up virtual machine. Now, and it takes really long. And that's the problem, because we need fast and regular deployment cycles. So we need the flexibility to scale our system very fast, our application. We need, for example, we start with one SQL server, and in the middle of week, we see like that's not enough. We need more. So we need very fast create another virtual machine in this system, and very fast spin up another software there. And that's something where the VMs have problems. Okay? So this is the VMs, and they were very popular before, and they are still. They bring a lot of also positive sides of it, like they are very secure. I think they are more secure than the Docker, but this is for another discussion. So when we go next, what is the Docker in this case? So in this picture, you can see that it's very similar to this old picture with some differences. So we have the server at the bottom. We have the host operating system, which is our operating system in our computer. And then on the top of it, we have some layer, which is called a Docker engine, right? So when we look back in this picture, Docker engine is a replacement for hypervisor in this case, right? And if we look here, we have something which is called the Docker container. And now if you look at the Docker container, the difference between the Docker container and virtual machine is that the Docker container doesn't have the part of its own operating system. Now, that's the part which is the biggest difference here. Docker container is just a process, okay? It's not the whole like operating system in this kind. It's just a process which will run in your computer and will handle the whole functionality which you need. So in this case, there is a process which is called a Docker container, which is handling the SQL. There are all the binaries and libraries and stuff which are responsible for handling the SQL. There is a process for REST API, and there is a process for SMTP server. As you can see, all of these processes are using the Docker engine layer and also the host operating system. And this is important, right? So you are using the same operating system behind the scenes. When we talk in the terms of Linux, you are using the Linux kernel for each of these processes. If you don't know what is Linux kernel, it doesn't matter, right? The whole idea of this is just to give you an intuition, what is behind the Docker. And it's good to start with some intuition and then go to the examples so you better understand the examples behind the scenes. So the Docker solution creates containers, process instances which are responsible for handling one of the microservices in the microservice architecture. Well, I have seen a lot of applications of Docker, and I have even seen like people using the Docker for deploying monoliths, right? It's absolutely fine, but the idea of Docker is just a process which is handling some functionality short term. Okay, so this is the Docker solution. When we go next, so what is this Docker container? As I said, it's a process sharing the host operating system. Now, it's lightweight, and this is the biggest advantage. When we talk about VMs, we are talking about gigabytes of data. That's a lot of data. These small little processes can take up to few megabytes. It really depends on the design, right? Right now, I'm working on some solution which has a very big containers, but the idea of the Docker containers is that they should be small, very flexible, and very fast to boot. Boot means like turn on, right? So the biggest disadvantage of the VMs was like they are slow, and the biggest advantage of Docker containers is like they are fast, right? You can deploy them very fast, you can scale very fast, and this is the biggest advantage. Now, there is also another advantage, like the overhead for management of multiple containers is very low, and this gives you a lot of power. Now, having these smaller containers, you can have a lot of them in your local machine, in your bigger server, compared to the virtual machines, right? So that's the way how the Docker container works. Now, Docker containers are ideal for running multiple applications on single device, sharing the same operating system kernel. That's something which I mentioned. And I also want to say that the Docker containers has no operating system. Yeah, I have talked with a lot of beginners in this field, and really there is like this intuition, like the Docker containers have some separate operating system. That's the biggest mistake, right? We will go through the examples, and you will see like it really seems like the Docker container is using some different operating system, but in reality, it's just using a snapshot of a specific operating system file system. Okay, system file system, yeah, you can see it can get confusing. Don't worry, we will go through the examples. Fine, when we go next is like, fine, Michal, but how are these Docker containers made? And now we go to a second term of this whole introduction lecture, which is called a Docker image. And now, Docker containers, as I mentioned, are processes, right? And you need to somehow specify the process, right? So, for example, you need to somehow write what should the process do, yes? And how it should end and start and so on. That's where the Docker image comes into play. So, I really think of this in the terms of object-oriented programming. I don't know if all of you are familiar with the object-oriented programming, but basically, if we talk in these terms, the Docker container is a real object of a Docker image. In this case, you can think of a Docker image as a class. So as a file, Docker image is a file which has like specific instructions or specific description of the running instance of Docker container, right? You can really think of it as a plan for some house, but basically if you want to live in a house, you need to build the house from this plan. So Docker image is just a plan of a house, but the real house is the Docker container, right? That's a running instance of a Docker container. And from this plan, you can create as many Docker containers as you want, and you can adjust some parameters of this house, you know, of this specification of the house, and create different containers. And that's the whole power of it. Now, when you think of this, the Docker image gives you the flexibility of sharing the description of the running instance of Docker container, and that's what is the most beautiful thing on the Docker, right? Having these Docker images gives you the flexibility of development, and it's very fast and easy. We will go through the examples. Now, let's go through these points. So Docker image is an unchangeable file with all resources. The unchangeable is very important, right? So I don't know if you are familiar with Python, so there is this term called immutable. Really, like Docker images are immutable. So Docker image is set of layers. We will come back to the layer term shortly. And you can think of it as a template or a snapshot from which we can create as many containers as we want. Fine, let's go next. So how and where are images stored? As I mentioned, the Docker image is a file. And as it is a file, it's very simple to share this file through your team or through your colleagues, through your friends. And you can think of it as a Python file, really. Like it's a very simple file. And there is a place which is called a Docker Hub where people are sharing their Docker images, right? So for example, there is someone very smart who is very into the Docker, and he created a special image which suits your needs. And this guy put it into the Docker Hub so you can reuse it. We will go to this during the example, okay? So Docker Hub or any other Docker registry is used for sharing the images. Now, we are working in the big company, right? And something public may not be that secure. So we have even our custom solution, which is called Harbor, where we store our images, right? So there are even different on-premise enterprise solutions which can help you leverage this by staying safe and secure. Now, how it works. So this picture is taken from docker.com get started, guide, yep. And in this picture, you can see two main components. The first component is your PC, that's the dash squared, right? And there is a Docker registry. The Docker registry is the Docker Hub I was talking about. And a Docker running in your machine consists of two things. One is the Docker client, and then there is a Docker daemon. Yeah, that's the layer which I was showing here. Yeah, that's Docker engine running with the Docker daemon, right? And when you are communicating with this Docker daemon, you are saying, please Docker, pull an image from Docker Hub, run image from Docker Hub as a container, and so on. So you have a store of your images locally. That's this part. And there is the registry of images somewhere else in the Docker Hub. And you can get the images from somewhere else to your computer and then run it as containers. And these containers are those small processes which we want to leverage the full potential of them, right? So when we go next, let's go to a small example. So during these examples, I'm gonna use Docker for desktop, and I just want to briefly show how you can install the Docker for desktop on your computer. The best way is to start in Google and go like Docker install Windows, or you can go like Docker download Windows. Yeah, some of you may be like laughing right now. I'm showing how to download things. This is normal. So you go to this docs.docker.com, and there is Docker for Windows, and you just click on this Docker for desktop Windows. This will download the executable for you. It will be here, right? I can click on it, that's fine. And then after downloading, you can just click on it, install it. And when you install it and you go to your start menu, it will install something which is called Docker for desktop. You just open it. It will start an application in your computer. And you can see that it's running in your computer by clicking here. And in your right bottom corner, you will see this image of Docker. And that means that the Docker is running, okay? After running this and installing this, you are able to use Docker in your Windows computer. The installation is very similar for Mac or for Linux. There are even resources for Mac and Linux. Mac and Linux. So go ahead, if you are using different distribution, you can install it from there very simply. Now, during this example, I'm gonna use Visual Studio Code. Inside my it's just an editor for code. And inside my Visual Studio Code, I have a terminal. Basically, this terminal is a Git bash. It's an alternative to the command line in Windows. So you can run the same things when you go for CMD and open this command line, and you will write it here. It's basically the same, but because I don't like this CMD, I am using Git bash. If you are a developer developing on Windows, I recommend Git bash is perfect for this kind of operations, right? So let's clear this. So when you install a Docker, you installed also the Docker client, which I was showing here, right? This part from the image, right? And when you have this client, you have this Docker keyword, right? You can use this Docker command for anything. So if you go like Docker help, it will display all the commands which you can run with your Docker, right? And now, as I said, clear. I'm confused. Yeah. So as I said, there are the images and there are the containers. And during this example, I'm gonna show you how I can run a Debian, a Linux distribution, inside my Windows computer, right? With a couple of commands from Docker. Now, the whole thing is, so in order to run a Debian container in my operating system in my computer, as I said, I need an image of Debian. So where can I find this image of Debian? In a Docker Hub. So when I open this website, it's called dockerhub.com. I will be redirected here, and because I'm logged in, this is my Docker Hub account, and I have here some of my images. But basically, when you come to the Docker Hub, you will be asked to create an account, and you can create there an account, and you can access the images of all the other people all around the world. Some of them are public, some of them are private, so it depends, right? So the task is to run a Linux inside my Windows as a Docker container, yes, as this small separate process. So what I do, I need an image for this. And in Docker Hub, you can find all the public images which other programmers provided for you, so you can reuse them. So you go ahead here and you put here, say, I want Debian. And you can see here is an official image Debian. Now, Docker Hub is public place. And this is something which I need to mention here. Please be careful what images are you downloading and running in your computer. If you are interested in Docker, you have seen a couple of articles saying some evil people were putting here images which were mining Bitcoins in your computer as you were running your image in your computer and all the crazy stuff. So every time when you are trying to use something from the Docker Hub, make sure it's either an official image or it has a lot of stars or a lot of downloads, right? As you can see, there are a lot of strange Debian things which can be suspicious, right? Can have some malware installed there or something else. So always when you want to use something, make sure it has a high download count, it has a high star count, or it's an official image. Yeah, because this is a public repository. Now, when you go to Debian and click on it, you can see that it has more than 500 million downloads. So a lot of people are using this image, and there are different versions of this image. So let's say I'm gonna run something very simple. So what I need to do first, the first step is to get the image inside my local image registry. So I'm right now here in the Docker Hub, and I need to get the image into my image local registry. So what I do, I go like Docker pull, and I want a Debian, right? And I want a specific version of a Debian. So when I clicked here you can see these tags. Tags is just basically a fancy word for versions, and there are a lot of different tags for this Debian. And I will just start with some of my favorites. So I go like Debian stretch, Debian stretch, yeah. So what will now happen? Now will happen that the Docker will search for the image called Debian stretch in my local image registry. And because I don't have this Debian stretch in my local computer, it will start pulling it from outside. Yeah, it will start it from outside, download it from outside. So it will go to this registry, which is in this case Docker Hub. It will download the Debian, as you can see here is even an example command, right? And it will download it, and now the image is inside my computer. How do I know it? You can list all the images inside your computer by running docker image ls. And as you can see, there is the Debian stretch, which I just downloaded, right? Don't mind this 6 days ago. This means when there was the last update for the image, right? So right now we have the Debian inside our computer, and now we have just an image, okay? Be careful, this is image. We need to run a container of this image. And in order to run a container, a Docker container from an image, you run it with the command docker run, okay? Now, Docker run has a parameter where you need to specify the image. And there are two ways how you can do it. First one is using this image ID. This is a unique specifier for this image. Or you can use the same label as you did during the download. So Debian stretch. So when we run this, it will start and terminate immediately. The reason for this is that this is just something which is called a base image. You can ignore this part right now. So base image means that it's doing nothing. It's just there so you can build something from it. You can think of it as Lego, really. These images, you can just connect them one on top of each other. And Debian stretch image is basically doing nothing. So what we can do is that we can attach a terminal to it so we can communicate with it a little bit. So you can do it by running docker run ty Debian stretch, right? Now, running this, you can see that my command prompt changed. Right now, I'm inside a container, in the running instance of a container. So right now, I have successfully created a Debian container inside my Windows machine. How do I know it? I will open another terminal window. So when you run command docker ps, it will show you what are the containers running in your computer. And as you can see, currently 28 seconds ago, there is a Debian image container with the ID running in your computer. So this is how you can simply get the Debian and run it inside your Windows. How long did it take for download and run? It was a couple of seconds, right? A whole, like a operating system in kind of a sense, running in your computer. Now, this is important. This is not an operating system, as I mentioned. It's a snapshot of a file system of an operating system, which is leveraging my host operating system. This can be sometimes confusing, so please just remember this is not a whole operating system. Now, prove it's a Debian, right? So how can I prove it to you? Like, you can install there something. So apt-get update, yeah. And we can install some of my favorite editors like apt-get install vim. Yeah. Now, as you can see, you can run the Linux commands inside your Debian container inside your Windows. Everything is perfectly working, right? with just a couple of seconds. As you can see, the folder structure or the file system is resembling the file system of the Debian, right? So everything is as you would expect in Debian. Now, how to stop this? So first of all, you need to get out of this container. So pressing Ctrl+C, Ctrl+D, sorry. Now, when you run Docker PS, you will see that there are no running containers because we left the session. Okay, so this was a very simple example showing you how you can simply run a whole instance of a container supported with the operating system in your computer. So we went through some basic commands like docker pull. Just to recap, docker pull is getting your image from the registry to your local computer if it's not inside your local computer. And then docker image is the keyword which is used for handling or working with the images. So with the docker image ls, you can list the images. You can use docker image rm to delete the images. Docker ps is used for listing the running containers, and docker run is for running an image as a container. Okay, so these were just the basic commands. Now the quick summary: Docker is a virtualization software, right? There is a difference between containers and virtual machines, as containers are just lightweight processes compared to virtual machines, which can be the whole instance of the operating system. Docker containers are created from Docker images, and Docker images or Docker image is a file stored in a registry, which can be a Docker Hub or something else if you're working for enterprise. Now, Docker client is the thing which allows you to write these commands like docker stuff, docker image, docker blah, blah, blah. And Docker daemon is the thing here, which is like listening to these commands and handling the requests by either creating an image from Docker registry or running an image as a container. So what's next? As I mentioned, we have this simple toy application running Debian, right? But let's say I want to run something there, right? Let's say I want to run JupyterLab. So what is a JupyterLab? And because this session is also dedicated for some of my data science colleagues who are working on creating machine learning models and they want to have some environment to create these machine learning models, JupyterLab is a tool, it's a Python library, which allows you to, it's a very popular Python library which allows you to work with data, creating machine learning models and stuff like this. So within this part, I'm going to show you how you can run a whole JupyterLab inside your Docker container, right? So let's start with some intuition, right? Docker image consists of layers, right? So as you can see on the left side, as I mentioned, there is somewhere a base layer, a base image. From this image, each of the parent and the child images are created, like the Debian, right? So each layer consists of changes against the previous layer. So if you are familiar with Git, and you are writing something in Git, the Git creates these kind of commits, right, of your code. And the way how Git works is like it's not creating every time a whole, like a snapshot of a code. No, it's just writing down the changes against the previous commit, right? And it's the same technology here. So the image of Debian is just changes against the base layer, right? So each layer is a separate image. So from each of these layers, you can create a container because it's an image, okay? And that's the power of the Docker images. So you can just combine these changes together to create something much more interesting and much more useful than just running instance of a Debian container, right? So as you look here, the way how we're gonna do this is like by having this Debian image, we will connect a layer which will have a Python installed inside there. And then we will connect again some layer, some layer, some layer. And at the end, we will have a layer which will run a JupyterLab inside our container. Fine. Now, how do we specify these images? This is the time when things get complicated. So when you want to specify your own image, you can do it even without this Dockerfile stuff. But most of the time, we are using something which is called a Dockerfile. Maybe you have seen it, maybe you not. First time when I saw this Dockerfile, I was thinking like, okay, so this is another programming language which I should learn. No, The Docker file is much simpler than a programming language, and it consists of few keywords, which allows you to create these kind of layers. Each line in Dockerfile, or almost each line, but let's say each line of Dockerfile is a separate layer. So you can directly map this kind of diagram, which I created here, to the lines in the Dockerfile, right? As you can see, there are 3 lines. Yeah, there is some space between them. The space is optional. You don't need to. I just put it here for readability. So, and here I'm explaining what is happening behind the scenes. On line 1, I'm saying like, I'm specifying an parent image, right? So on line 1, I'm specifying, please use a parent image Python 3.8.5, slim version, whatever. And then on line 3, I'm saying, please install library JupyterLab. And on line 5, I'm saying, please run the JupyterLab executable. Now, this can be confusing. Where does this parent image specification come from? The line 1 is the same command as if you will say into the command line docker pull python 3.8.5. Now, we will go back to the Docker Hub. So as I mentioned, Docker Hub is a very cool place. And the idea behind this is genial. It's open source. Everyone can contribute, right? So in the Docker Hub, smart people like you are creating content for other smart people who want to use it, right? So let's say you want to work with Python, yeah? But you never set up a Python on Debian before, right? Because inside this stage, we need to create or install a Python on Debian. But who of you installed Debian on Python? Yep, almost no one, right? So there is an image which is called Python here, which already ships with like the whole setup on this platform. So when you click on the Python, you can see that there are a lot of versions of Python. And this image is updated regularly. As you can see, there is more than 1 billion downloads and how many stars? 6,200. So this is safe, like no crypto mining there, right? So if you open it, a lot of versions, right? 3.8, 3.6, and so on and so on. So thankfully, some smart people already created this image for you. So you don't need to worry about setting up this image, right? So now, using this Docker file, you are just saying, please, Docker daemon, use an image called Python 3.8.5.slim from a Docker Hub. And then on line 3, please add another layer, which installs inside my image a JupyterLab. And then on line 5, please run this JupyterLab. And now some of you may say, what is this crazy thing here, right? This is just the parameters for JupyterLab in order to run it on a specific IP address and port. You don't need to worry about this. This is very JupyterLab related. It doesn't have to do anything with Docker, right? Fine. And now you will say, okay, but how is this Python 3.8 Slim created? So for example, if you choose one of these tags, let's say we want to look at 3.7 and you click on it, you will be redirected to a GitHub. And inside this GitHub, you will see that this is a Docker file for that particular image. Yeah. So here we are building a new image from already created image Python 3.8.5 or any other Python, right? And someone already created this Docker file for this image. So when you look on this Docker file, you will see that this image has a lot of commands there. And this is basically the setup of Python on the Debian stretch, right? So, and now some of you may say, well, Michal, but why is this so crazy long? It's because this setup is official and it's secure and you don't need to worry about crazy things because the people who are like responsible for creating Python 3.7.10 already set this up perfectly for you. So there are no problems with the configuration and stuff like this, so you can rely on it. And as you can see, this whole Docker file, you don't care about these commands right now, but there is this from command. So this Docker file, this image is created from another image. And that's the hierarchy, right? So as I said here, you can just connect one image into another image, adding changes and so on and so on and so on. And having this specific Docker file for our JupyterLab we created a very specific image which will run the Jupyter Lab. I will show you shortly. Now, there is one more slide. So what is this Docker file? How we can think of the Docker file? Really think of it as a recipe or a specification for Docker image. Each line is a separate layer, okay? The advantage of this is like, this is a whole setup. Now, I don't know if you understand what is happening here, but having the ability to write this configuration inside a Docker file gives you the opportunity to share this configuration with the rest of your team. You don't need to pay anymore this kind of professional DevOps guy who will set up the production server. Why? Because you can reuse some of the stuff which already was created for you by someone else. Yeah, using this Docker image of Python, you don't need to worry about specific Python setup in your production server because this Docker images already ships with the professional setup, right? So it's cheaper, it's faster, it's lightweight, you can scale fastly and so on, right? So this is the biggest advantage of this approach of Docker files. We can store them on Git and share them. This is normal file which you can put on Git and send to anyone, and that anyone can work with you on this image and adjust it accordingly and make it even better. Now, everyone can easily see our container configuration. Yeah, that's perfect. Like, if you want to make it like private, one way is not to share it with the rest of the community, sending it to a Docker Hub. You can even set up a custom registry inside your enterprise, inside your company, right? So every of your worker will be just sending the images to this registry and no one else will have access there. So this is absolutely fine and it's used normally. We use it also, as I said, the Harbor solution. Now, let's go to the Jupyter Lab example. So I'm here and I'm inside my Visual Studio Code. On the left side, I have a folder where I created a Jupyter subfolder. And here I have a Docker file. This is exactly the same Docker file. Now, I want to create an image from this Docker file because, as I said, Docker file is just a recipe. I need to create an image now. So the first step is we will look on our images. So command is docker image ls, just to show you that I don't have it. So there is just this Debian stretch, which I downloaded previously, right? So no Jupyter stuff here. Now, what we need to do is we need to build an image from the recipe, right? So a recipe or a Docker file, and then we have the image, and then we have a running instance of it, which is called a container. Now, when you are a beginner in Docker, there are a lot of terms which you need to use to it. You need to use it correctly and stuff like this, right? But it's absolutely normal. I think Docker is not that complex as some people think. It's, yeah, the learning curve is quite steep. So when you start with it and when you start to use it and play with it, it will be much simpler for you. Now, some of you may say, fine, Michal, but you are showing us just some of the commands here. There are surely a lot of them. It's not too many of them. There are just dozens of them. You can find them on internet. Most of the commands are just mimicking like a terminal, right? So this is the command which you will write into a terminal of Debian to install a library, right? So this is absolutely fine and it's absolutely normal and readable. Okay, going back to this, how do we build this image? So I'm inside my Docker demo folder, ls, and as you can see, there is this Jupyter folder, right? And inside this Jupyter folder, I have my Docker file. So I need to build the image, and I build it like Docker build. And now, yeah, some of you may say, yeah, so I'm saying Docker build, and I will specify where is the Docker file. So like Jupyter, and there, it's inside there, or you can put the full path there. But this will create image without the name. And it's a good practice, as you saw, to put some name to your image. And this is called tag. So I will tag it as a now Jupyter is with Y, yeah, Jupyter. And I will put there some version, 1.0.0, right? And let's get rid of pandas for now. And now, when I run it, the Docker will first download the image for me, I mean the Python 3.8.5.slim. Then it will install the Jupyter Lab there, and then it will create this command layer. And I will come back shortly to the command layer. So now when I build it and I go like Docker image ls, you will see that I have here Jupyter, right? And now what we can do, we can run like Docker run, and we want to run this image. So Jupyter, and the tag is 1.0.0, and that's it. Yes. So when I run it, you can see that this is the output from the Jupyter, right? Some of you may say, well, we win. So how we access this Jupyter, right? The Jupyter is running on your localhost 888. So if I go here and I go localhost 888, I press enter, nothing happens, right? So what's the problem? Now, here comes a Paint into play, and I like Paint, and let me explain you what is happening here. So this is your PC, and the PC has some network here, right? So yeah, I don't want to go into the details of networking, right? But yeah, there is something which is called localhost, which is running in your computer, and there is some range of ports which you want to access from the computer. So when I put here localhost 888, I'm accessing localhost on port 888, right? So this is my port 888. So what we did is that we ran an instance of a container which is running a Jupyter on port 888. The thing is, the port of a container is not the port of my computer. So I need to link somehow these two ports, right? And the whole Docker networking is a little bit complex, and I will not go into too much details inside this lecture here. But really, if you are interested more into this, I recommend there are a lot of great tutorials explaining this into more details. So I need to create a link between the port of my container with the port of my computer, right? Because as I said, this is running as a separate process, because like this, that's the way how the Docker container works. So how do I do it? I need to go back here, and I press Ctrl+C. And now someone was asking how to run it constantly in the background. So now when you run Docker PS, you will see that although I press Ctrl+C, the container is still running there, because you cannot just kill it with Ctrl+C. So I need to rerun this container, so I will need to first shut down the running container, which is running in the background with this wrong Jupyter instance. And how to do it? Docker stop and the container ID. This will stop the container. So by running this, now I shut it down. And if I go Docker PS, there is no more container. And I come back to this command, which I run, so Docker run. And I need to specify the mapping of the port 888 from my container into the port of my computer. So I do it with P88888888. I'm saying, please, Docker, run image Jupyter 100, and please map the port from the container 888 to my port on my PC. When I start it, this will again trigger the instance of the Jupyter. And in this case, when I go back and I press enter, it will create a Jupyter server, Jupyter Lab. Now Jupyter is secure and it's creating a token for me, so I need to get the token. It's here. I will put it here, login, and as you can see, I can use Jupyter Lab. So again, how fast was this? The whole setup, very simple. I'm running it in the isolating environment, running it as a Docker container. Now imagine, yeah, you want to run something like this into production. The same scenario happened, right? The setup can be there a little bit more complicated, but this lecture is just about the intuition behind the Docker containers. Now, this is the last section. So we were talking about, now let's stop it, Ctrl+C. So we were talking about, I didn't stop it, it's running here, so Docker PS. Yep. So we were talking about what are the images, what are the containers. I have here some sum up slide. Yep. So we said that the Docker images are just files. We said that the Docker images consist of layers. Each layer is immutable, each layer is separate image. Each layer consists of changes against the previous layer. And the Docker file is a recipe where we can create a custom image. So I showed you the main advantages of the Docker. Now I was thinking what to add here because we have still some time. And I decided like, let's talk about something which is called stateful containers. Now, you as you run the container, let's say this Jupyter Lab container, yep, the Docker is assuming that your whole container is stateless, meaning you don't want to persist any data, right? Okay, stateless versus stateful. When you are thinking about this, what is the difference? If you think about a database is an application which needs to store data somewhere, right? So the storing of data or the ability to storing something is called stateful, right? And on the other hand, you can think of some script which will just output something and then kill itself as a stateless job, right? And by default, Docker expects that your containers are stateless. And I will explain what it means. So right now, I'm inside my root directory inside the Jupyter Lab. And I will create something here which is called the Jupyter Notebook. Okay? Yeah. And the Jupyter Notebook will right now be stored inside the root folder inside the container. And I can just import pandas spd. I don't have it installed there, but yeah, let's say it's there, right? I don't have it installed, but the purpose of this example is like, I created the notebook, it's here. I press save, and now the container is still running, right? Behind the scenes, right? So if I refresh it, it's still there. But now I decide to stop the container, right? So docker stop container. I will stop the container. Now this will stop my container. And now what I will do is that I will retrigger it again. And as I said, Docker is assuming that this container is stateless. Yeah, so it doesn't need to store the data somewhere. So Docker PS, no container, sorry. Docker PS, no container anywhere. So now I will trigger the same container running the same command. And now when I will go back to the localhost, it needs the token, and I will go to the root where I stored it before. Root here. There is no Jupyter Notebook. Why is it? Docker containers, I have it here, are ephemeral. Now, this crazy word, what does it mean? Like, yeah, there is a very nice Slovak translation for it, and it basically means like the memory which is assigned to a container is there only during the container existence. As soon as you shut down the container, all the memory is gone by default, right? So the Docker containers, or the philosophy of this is just you are running the containers as a stateless processes, right? But now some of you may say, well, Michal, fine, but this is useless, right? I want to store somewhere my data. Let's say I want to have my Jupyter Notebook stored when I'm working with it and so on. So now here comes into play something which is called a Docker storage. And Docker storage is a powerful tool. Docker storage allows you to create a storage inside your container. And there are three ways. Currently, there are three ways. Before, there were just two, but now there are three. Now, there are three ways which allows you to create these storages. First storage, or the type of storage, is called a bind mount. And a bind mount storage is that you say, I will go back to this amazing paint. I like paint for explaining things. So with the bind mount, you are saying this is your PC and here is your container, which is ephemeral, right? It has no memory, so container. And with the bind mount storage, you are saying in my PC, I have a folder which is called X. Please take this folder from my local PC and map it into a container memory, let's say to root. Sorry, I cannot write with my mouse. So with bind mounts, you are binding your file system folder into a file system of a Docker container, right? So this is the first type of storage, and I will show an example of this, right? And having this, everything what will be stored in the root folder will be mirrored into your file system. So this is very useful, right? This is the first type of storage. Another type of storage is something which is called a volume. And volume are better than these storages, but they are complicated, so I decided not to put them into example. But you can think of the volume as follows. There is a Docker daemon here running in your computer, and Docker daemon will create a special folder here, which will be called Y. And this special folder will have a special format. And the volume will map, running the Docker volume, the Docker daemon will map this special format folder into your container. Now, some of you may say, okay, so what is the difference? The difference is that this format is optimal and you cannot just access it from your file system. Well, you can on some distributions, but on Windows, it's very hard and it's not readable in a sense like you would access normal file and folder in your file system, okay? So bind mount is mapping your normal folder and volume is creating some special location in your computer where all the data will be stored. Now, why is volume better? The reason for it is because this format of this folder is optimal for Docker. So it's very fast. Writing into bind mounts can be slower and you can feel it and it's not good. You want everything to be fast in these microservice-oriented cloud distributed systems, right? So we want everything to be fast. So volumes are much faster. And now there is one more thing. It's called temp file system mount. And temp file system mount is amazing. And I really like the idea. The idea is this is your PC. And the PC has, for example, RAM. Yep, RAM. And with temp file system mount, what you are doing is you are saying this is your container. And you are saying in the container, in the folder root, you are mapping a portion of your RAM inside your root folder in the container. Now, some of you may say, okay, but this is strange, but you will delete everything from RAM when you shut down your computer. And that's exactly the problem, right? So why is the temp TMP file system mount better? Because this is extremely fast. This is the fastest option you can get from your container mount. And it's used right now more often, but this TMP FS mount is not available for Windows for Docker. It's only available for Linux. So I just wanted to mention it as a cherry today. But we're gonna talk about these bind mounts, right? So this is just a sum up. Docker volume are created and operated by Docker, very specific format which is optimal to use on Windows and macOS. And Docker bind mount is concrete file system location within your computer bind to a specific location in the container, right? That's from the picture. And the Docker TMPFS mount artificial location in the container created from location. It's temporary and it's deleted after container execution, but it's very fast. Now let's go to demo. And what we're gonna do in this demo, it's a very simple idea. So first we're gonna Docker PS and we see that the Jupyter Lab is still running there, but it's a wrong one. So Docker stop this one. This will stop the container. Now we want to run this container with the mount. And now it can be achieved in different ways, but this is the hard way I'm gonna use. So we need the name of the image, Docker image ls. We're gonna use the Jupyter 100 and we're gonna say Docker now run. We're gonna say that we need a mount. The type of the mount is called bind because this is a bind mount, right? And what we are binding is called a source location. And the source location which we want to bind, so what is the folder from our file system which we want to bind? It's called it's called the location where I'm right now. So pwd. This will output the current location. So documents, tutorials, Docker demo, and I want a folder inside the Jupyter, which is a folder called notebooks. Notebooks, as you can see, I have here my notebooks. Yeah, and there is already some test notebook inside there. So I am mounting this notebooks folder into the container. And now this is just the source part. Now you need to specify also the target part. And I want that these notebooks will be mapped to a location in the container, which will be called app. Yep. And don't forget the port specification. And what else do we need? Jupyter. Now, please work. This is a live demo and this can go wrong. Yeah. So let's run it. Enter. Yeah, Windows is asking you if you give the permissions. You click on share it because Windows is secure. And now this is a good sign, right? It looks like it's working. So let's test it. If I go back to my browser and I go to localhost 888, enter, again, this token. This is this one. It's behind the token part. Control V. We don't want to store it. As you can see, there is this app location, and inside is the test. As you can see, I didn't create anything. I didn't specify it in the Docker file. I just said, please take this notebook's location and map it directly into this container. And as you can see, it's a test here. So if I open it, I specify it's a Python. It's an empty test. So when you create here another Jupyter notebook, let's say test2, save it. The changes will also apply to my local folder here. Here is test2. Okay. So volumes and Docker storages are the way how you can connect your file system or a storage with your ephemeral Docker containers. The whole thing which you need to keep in mind is really that the design of these of these Docker containers was to create them ephemeral. Really, if you are forcing this storage or forcing these volumes, it's not always a good idea. You can really think of it differently, right? Okay, so this is a quick summary. Docker containers are ephemeral. To handle stateful containers, we need to use volumes or bind mounts. Using bind mounts, we can map host files directly to the container, and bind mounts can be slower in Windows or Mac, on Windows or Mac. Okay, fine. The whole idea of this is like, and the goal of this presentation was to bring to you the idea that we are going, or the modern development is going the microservice path, right? So deploying monoliths is old-fashioned, and really we need to concentrate on creating these separate microservices which can work in isolate and can be reused and which can be scaled pretty much instantly. Now, the scaling is getting much more important nowadays because so there are a few types of scaling, right? So you can scale by adding resources to your server, having more RAM and more CPU and stuff like this. But the humankind is facing the border here, right? We are in the stage that the CPUs cannot be faster, right? And our applications needs to be faster, and they are much more resource demanding as they were before. So we need really to concentrate on these distributing computing systems. And by running the software or using the container technology, we can leverage the distributed computing system approach with the full potential, right? With its full potential. So really, like, investing time into learning Docker and rewriting our old monolith applications in the microservice manner is useful and makes sense in this kind of in current situation. Now, Docker is one thing, and there are even problems which you will need to solve in the production as you will go more to the distributed computing system way. So Docker is very closely connected with the Kubernetes technology or some other technology. Kubernetes is a very popular technology which allows you to orchestrate the containers. Orchestrating means that when you will have these multiple containers running in your servers or in your I don't know, nodes, virtual machines, right? You will need to somehow manage these Docker containers. And Kubernetes is the technology which allows you to very flexibly monitor, scale, and handle errors inside your cluster. Cluster meaning multiple servers. So now, even the Docker is very popular technology of nowadays. The best thing about Docker is that it's open source. You can even contribute to the source code. And I like the whole community around it. So I really recommend like spending some time learning about Docker. Now, how do we use Docker? So as I mentioned, I'm working as an MLOps engineer here at Dell Technologies. And we are using Docker as part of our deployment process of machine learning models into the cluster of servers. And as I said, we are using this technology called Kubernetes, which is a container orchestration system to deploy multiple containers on multiple servers, running multiple machine learning models to score regularly, right? So as you can see, there are a lot of use cases for Kubernetes nowadays. And I think that the trend is going exactly this way, this microservice-oriented way. So I highly recommend spending some time there. Now, what can be your next learning steps? So I highly recommend going through the documentation of Docker. It's not long, really. Even if you go just through the important concepts, you will spend there some time. You will see it's quite easy digestible, right? You won't have that many difficulties with the terms which are there used. So just spend some time and read it. Read more about Docker volumes. There is also important or interesting part which is called the Docker Compose, which can somehow on a smaller scale replace the Kubernetes technology, but it's very just a toy example of how to use the containers in a distributed way. Now, I highly recommend reading about Kubernetes. I also recommend subscribing to Informatica's Mission, where you can find this recording of this session. I also in the future will prepare some lectures about this in a Slovak language if you are interested. As I mentioned, there is this channel called IT Guy Michal, where you can find some old English versions of these lectures with some additional material, so feel free to check it out. And that's about it from my side. I don't know if there are any questions, so there are no questions. Thank you very much for joining this lecture. I hope I will see you next time.